This video is going to give you a brief overview of organic functional groups. And if you're looking for more information on this after the video, you should be reading through the functional group section in your textbook, but they're listed on page 1071 in your book. We've learned before this that hydrocarbons are relatively unreactive other than combustion reactions. And so for an organic molecule to be really reactive, it needs something additional. Now, a functional group is a site of reactivity. And we've learned that double bonds and triple bonds are, in a sense, functional groups because double bonds and triple bonds will undergo addition reactions. They are more reactive than alkanes. But they're not limited to just being a double or a triple bond. We could change the elements that attach to the carbon parent chain, and we'll call that a functional group. Now, some of you in biology may remember that last year as juniors in biochemistry, you memorized some of these functional groups. And this last bullet point here, chemists usually use R or R prime or R double prime to represent the alkyl groups. Essentially what an R group is some carbon hydrogen chain. And I know Mr. Peterfuss always introduces it as the rest of the molecule, but basically it's just something that's carbon and hydrogen. And it is important to the molecule, but it's not its defining feature. So to start out with the common functional groups, you are already familiar with at least two of these. The alkene will have a double bond, and it can be attached to any other carbon chains, okay? An alkyne will have a triple bond. So again, the reactive site is this triple bond between the two carbons. The rest of the molecule really isn't that big of a deal. Now, an alcohol is going to have a carbon chain followed by an OH. And an OH group you've seen before, but now you're going to learn more about alcohols. So again, it will have an OH group, and it can be placed anywhere on the chain. An ether group is generally, you can either have a carbon, well, basically it's two carbon chains connected by an oxygen. So another way of writing this would be R, O, R prime, because these two carbon chains on either side do not need to be the same. A haloalkane is something that you've already learned about. We've called them alkyl halides essentially as well. But I'm just going to put an X because the X is a halogen, fluorine, chlorine, bromine, or iodine. An amine, you've learned the simplest amine is ammonia, NH3. And an amine is some kind of an organic version of that. You can either have what we call a primary amine, where the nitrogen is attached to only one carbon. You can have what we call a secondary amine, where the nitrogen is attached to two carbons. Or you can have even a tertiary amine. And a tertiary amine is where all of the bonds to the nitrogen are carbon groups. So we can have R prime and R double prime. Those are all considered amines. An aldehyde is a functional group where you have some carbon chain we'll call R, and then a carbon connected to a doubly bonded oxygen, and then a hydrogen off of that. This doubly bonded, this CO double bond, is called a carbonyl or carbonyl group. So you'll see carbonyl carbons referred to in your reading, and you should be doing the readings on these. An aldehyde will always have a terminating or end H. Okay. A ketone is a lot like an aldehyde, only instead of having an H as a terminating feature, you could have another R group. So that is a ketone. A carboxylic acid, you should be familiar with acetic acid. You have a carbon chain and then connected to C double bond O. There's that carbonyl group again, OH. An ester is a compound that has an R, C double bond O, and then another O with another carbon chain. It's kind of like a combination of a, a carboxylic acid and an ether. An amide involves a carbonyl group as well. You have an R group, C double bond O, and then connected to an N H. Now, that is an amide, but those H's don't necessarily have to be H's. They could both be H's, they could both be R's, or one could be an R and one could be an H. So I'm just going to list them as R because they could be anything else. And then lastly, a nitrile group, which you'll have to add to your packet because I don't have it photocopied in there for you. A nitrile involves a C triply bonded to a nitrogen atom. And that could be anything on that other side. So that's an example of a nitrile. A lot of times they're terminate, meaning they're ending the molecule, but that is an example of a nitrile. So now you have all the functional groups, and it would be helpful so that you can recognize these. So it might not be a bad idea to make flashcards and quiz yourself on these.